So this is my new video on friction 5. You must have gone through friction 1, 2, 3, 4 and 5. This is an inclined plane. We have two bodies connected by a string. Each string here has tension T, tension T. The tensions are not different because the pulley here is frictionless. So normally we resolve this M1G here and we resolve it here. So here we should have M1G cos theta and here we should have M2G cos theta. Let us assume that the body tends to move this way. So for this body the direction is this, and for this body the direction of acceleration is this. So this direction of acceleration of this one is this, the direction of acceleration of this one is downward, and this is now easy to do. Okay, now since the direction of acceleration here is like this, we have three forces being applied to this body, which is M1. We have T, M1G sin theta, and the frictional force. Alright, since the direction of acceleration is like this, we have to take this thing into consideration first. So we write T is equal to, we write T minus M1G sin theta minus frictional force, and we know that frictional force is mu r, and mu r is mu M1G cos theta, so we have mu M1G cos theta is equal to M1A. So from here now, T is equal to M1G sin theta is equal to M1G sin theta plus mu M1G cos theta plus M1A. Minus will come here to become plus, and this is already plus. So I will call this equation 1. Now, I will come to the second body here. Since the direction of acceleration is downward, I have to take this one into consideration first. So I have M2G minus T is equal to M2A. So from here now, I have T is equal to M2G minus M2A, and I will call this equation 2. So if I equate both, I will have, this is for tension and this is also for tension. So I have to equate this and this to get my acceleration. So from here now, what do I have? I have M1G sin theta plus mu M1G cos theta plus M1A is equal to M2G minus M2A. Alright? So if M2A comes here, I will have M1A plus M2A is equal to, I have M2G here, so M2G minus M1G sin theta minus mu M1G cos theta. Yeah, so I have M2G minus M1G sin theta minus mu M1G cos theta. So A is common, and I have A into M1 plus M2 is equal to M2G minus M1G sin theta minus mu M1G cos theta. So what is my acceleration now? Acceleration is equal to M2G minus M1G sin theta minus mu M1G cos theta all over M1 plus M2. So in this kind of a structure, under frictional force. To calculate acceleration here, you simply use this formula. You may not need to know how to derive the formula, but the moment you know the formula, you can impute the value that you are given. Now, I think we can just play with some values. Let's play with some values. Supposing my M2 is 4. Supposing my M2 is 4 kg, or let me put it here. If M2 is equal to 4 kg, M1 is equal to 2 kg, mu is given to be 0.5, and G is 10 meter per second square. From here now, what is my acceleration? My acceleration is equal to, according to the formula here, what is M2? 4 kg. What is acceleration due to gravity? Okay, we can write this formula in a better way. Since we have G here, we have G here, we equally have G here. Why can't we just write A is equal to M2 minus M1 sine theta minus mu M1 cos theta, all into bracket G, then divided by M1 plus M2. So what is acceleration? Acceleration now will be 4 minus 2 sine, if my angle, which is theta, if it is 30 degrees, then I have sine 30 degrees minus 0.5 times 2 cos 30 degrees, all into bracket G over M1 plus M2, which is 6. So acceleration is equal to 4 minus 1 minus 1 minus 1 cos 30. Cos 30 will give me root 3 over 2. So into bracket what? G, or my G is 10 all over 6. Okay, so here now acceleration is equal to 4 minus 1, 3. So I have 3 minus root 3 over 2, all divided by 6 into 10 here, which is equal to, obviously, 6, 2 here, 3, 2 here, 5. So I have 3 minus root 3 over 2, all into bracket 5, all divided by 3. That will be my acceleration. If you get your calculator, you can use calculator to find the final value of this. All right. So now, when you are given this kind of arrangement and you are asked to find acceleration, the formula to use is simply this. And when you are given the value, you can input the value to get this. So I'm going to stop here for this friction 5. You need to watch out for my next video, which is friction 6. In this friction 6, we are going to look at another arrangement that has to do with friction. I will calculate the acceleration. Here we assume that there is frictional force. In the new arrangement, we will use both presence of frictional force and the absence of frictional force. Please remember to subscribe and like the video and always watch the video. Thank you so much for watching. Oh.